Hello students, today we are going to discuss the next form of the conic section, the ellipse. So let us know what is ellipse. Consider there are two fixed points. One point is taken as F1 and one point is taken as F2. Then ellipse is the set of all those points in a plane, the sum of whose distances from these two fixed points remains constant. That means these two fixed points are given and the set of all those points whose distances from these two points, the sum of whose distances from these two points remains constant. For example, consider a point P. Then distance of this point P from F1 and F2 are Pf1 and Pf2. Then the sum of Pf1 plus Pf2 is equal to constant. Then such points, the set of such points is known as ellipse. Consider one more point. Suppose that one more point is this. The distance of Q from F1 and F2 are Qf1 plus Qf2. This sum is also constant. This is the definition of the ellipse. So ellipse is the set of all points in a plane the sum of whose distances from two fixed points remains constant. Here these two fixed points are known as foci. The two fixed points are known as foci, which is the plural of focus. This is the plural of focus. It is clear, student? Now let us know what is the value of this constant. First of all, we should know what is the graph of the ellipse. Consider such 4 points. If we join these points, what we get? We get such type of figure. This figure is known as the ellipse. Means such type of figure. This figure is known as the ellipse. The two fixed points are F1 and F2. Point P and point Q is this. Then Pf1 plus Pf2. This is equal to constant. And also Qf1 plus Qf2, this is also constant. So let us know what is the value of this constant. Now consider this, the line which passes through the two fixed points is taken as x-axis, and the line which is perpendicular bisector of the line segment f1 f2 is taken as y-axis, and this point is taken as the origin. Now the ellipse intersects the x-axis at these 2 points. These 2 points are known as the vertices of the ellipse. These points are taken as A dash. These are called the vertices. One vertex is this and another vertex is A dash. And the intersection of ellipse with y-axis, intersection point is taken as B dash. The length of A dash is known as the major axis, length of the major axis, and the length B dash is known as the length of the minor axis. So let us take A dash equal to 2A, B dash equal to 2B, and C dash f1 f2 equal to 2C. Then A dash is called as major axis, and B dash is known as minor axis. This is known as the minor axis. Now this is the origin. Then coordinates of A becomes A comma 0, and the coordinates of A dash becomes minus A comma 0. The coordinates of B is 0 comma B, and B dash is 0 comma minus B. Coordinates of F1 are C comma 0 and F2 are minus C comma 0. It is clear, students? Now let us know what is the value of this constant. For this Pf1 plus Pf2, Pf1 which is if we take point A on the ellipse, then we can write AF1 plus AF2 is equal to constant. AF1 plus AF2, this is equal to constant because A point lie on the ellipse, then the sum of this point from F1 and F2 becomes constant. Now AF1 can be written as OA minus OF1, and AF2 can be written as OA plus OF2. This is equal to constant. OA is equal to A and OF1 is equal to C, and OA is also equal to again A, and OF2 which is equal to C equal to constant. C is cancelled out with C, then constant value becomes 2A. A plus A 2A. Thus we can write Pf1 plus Pf2 is equal to 2A. That means any point of the ellipse as the sum of the distances from F1 and F2 which is equal to 2A. It is clear, students? Now let us know the relationship between semi-major axis, semi-minor axis, and distance of the focus from the origin. relation between A, B and C. A is the semi-major axis, B is the semi-minor axis, and C is the distance of the focus from the origin. This is focus F1, this is vertex, this is origin. Now for finding the relationship between A, B and C, consider a point B on the ellipse, then the distance of point B from F1 and F2 means BF1 plus BF2. The sum of these two distances becomes constant. BF1 plus BF2. This is equal to 2A. This can be written as 2A. Now coordinates of F1 are C, 0. Coordinates of this point is 0, A, and the coordinates of F2 are minus C, 0. Then we can write BF1 by distance formula. This is equal to 0 minus C square plus A minus 0 square plus this is also can be written as 0 plus C square plus A minus 0 square. This is equal to 2A. So this can be written as C square plus A square plus C square plus A square. This is equal to, this coordinate is B. Here this is B and this is also B. C square plus B square. This is equal to 2A square. So this is 2 times C square plus B square equal to 2A. 2 is cancelled out with 2 square on both sides. We can write C square plus B square is equal to A square, or we can write C square equal to A square minus B square. From this we can also write C square equal to A square minus B square. It is clear, students? Now let us know eccentricity. So students, what is eccentricity? Eccentricity, it is the ratio of distance of focus from origin to the distance of vortex from origin. And is denoted by E. Denoted by E. That is, E is equal to C by A. This value is known as the eccentricity. And for ellipse, the value of C is this and the value of A is this. So value of this is always less than 1. For the ellipse, eccentricity is always less than 1. It is clear, students? Now let us know two forms of the ellipse. Actually there are two forms of the ellipse. One is called the horizontal ellipse and another is called the vertical ellipse. Forms of the ellipse. One is the horizontal ellipse and second is the vertical ellipse. Horizontal ellipse is such like this. This is called horizontal ellipse, and the vertical ellipse is such like this. This is called the vertical ellipse. In horizontal ellipse, the focus lies on x-axis, and in vertical ellipse, focus lies on y-axis. The major axis is A dash on x-axis. In this, the major axis is on y-axis A dash. Minor axis is this B dash. Here minor axis is this B dash. Center is at origin and the center is at origin. These are the two forms of the ellipse. It is clear, students? Now for today, we are leaving the topic here. In the next video, we will discuss the equation of the ellipse. Okay, students? Thank you.